Hello everyone. In this video, we are going to conclude the topics on flight mechanics from the APPI 2 course. We are going to talk about stalls and collapses. First, what is a stall? Our paraglider has the shape of an aerodynamic profile, it has the shape of an airplane wing, and when this aerodynamic profile has a very high angle of attack. For example, here we have a profile. This is the front part. When this part has too much inclination, a very high angle of attack, the profile stops generating lift, and that means a stall. In this case, if the paraglider is braked 100%, it will stop flying, and it will fall. These stalls are also called full stall or simply stall. There's an intermediate stall called parachutal stall, in which the paraglider is not deformed. It keeps its wing shape and stops generating lift. It starts to descend, but it does not fall as abruptly as in a full stall. A parachutal stall is usually the consequence of flying a very old paraglider that has become porous and therefore deformed. To exit from this, you have to push the A risers or pull the A risers. But if we fly a paraglider in good condition, we are not going to enter a parachutal stall easily. It is very rare to enter a parachutal stall. The only thing that will cause us to enter a stall, a full stall or a stall, is if we brake 100%. If we brake both brakes at the same time 100%, the paraglider will enter a full stall. And if we brake only one side 100%, that is one hand up and the other one pulled all the way down, the paraglider will enter a stall, but only on one side, which is called a negative, or in English, a spin. And what happens? The paraglider starts to rotate like a helicopter. That is what is called a negative. Both the full stall and the negative are very dangerous because it takes time to recover from them. We can lose many meters before the paraglider recovers, and the technique to exit quickly is not that simple. In fact, it is learned in a special course, SIV. In this card, I will leave a video where I talk about the main paragliding incidents. Now regarding collapses. Collapses are not the result of overbraking as stalls are. As I mentioned in the previous video, collapses are usually the result of a very pronounced pitch movement. And this pitch is the result of having entered a very strong thermal or having entered a turbulence rotor. In general, they are due to many factors, especially external ones. They are not mainly caused by the pilot, except in cases where we exit a maneuver incorrectly. So collapses, which is when the paraglider closes while we are flying and part of the profile closes, are the result of external factors. Basically, there are two types. The asymmetric collapse, which is when one side of the paraglider collapses. This asymmetric collapse is measured in percentages. It can be just a small tip, it can be 20%, 30%, it can be 30% or 50%, sometimes a massive collapse of 80%. The technique to exit or solve a collapse is simply to shift your body to the opposite side of the collapse, because the paraglider will tend to turn toward the collapsed side, and what I have to do is prevent the paraglider from turning. So I have to shift my body to the opposite side. I can slightly assist with the brake, but without overdoing it, because if I brake too much, I could enter a stall. Now, the symmetric collapse, also called frontal, is when the entire leading edge of our paraglider closes symmetrically. The entire front edge is collapsed. Although it may seem more dangerous, it is actually much more docile. It is much easier to solve because the paraglider is not going to turn. Practically, I do not have to do anything. If I want, I can break the wing slightly to help it reopen. But even if I do nothing and keep my hands up, the paraglider will reopen almost immediately by the action of our own weight. And that would be all regarding these main incidents, which are stalls and collapses. In stalls, I have the full stall, which is when I stall both sides of the paraglider, and I have the negative, which is when I stall one side and the paraglider rotates like a helicopter. These stalls are the result of overbraking by the pilot, a pilot error. They are not caused by turbulence. On the other hand, I have collapses, which is when the paraglider closes. Collapses, or deflations, are usually caused by external factors, turbulence, or rotors. Mainly I have the asymmetric collapse, when one side of the paraglider collapses, and the symmetric or frontal collapse, when the entire leading edge collapses. That is it for this video. Thank you very much for staying until the end, and I will see you in the next video.